All right, lesson number 4. We're going to start looking at what are called points of concurrency, and that's the circumcenter and the incenter. Now, right now, that probably means nothing to you. That's just vocabulary, and that's the. I think there's two things in this course. It's easy in that a lot of the stuff is you can kind of see it and almost guess the right way to do some things, even if you're not sure. And then the hard part of the course is the vocabulary, and really it's a memorization thing. You just have to remember what these words mean and study them. But we're going to get into it, and what a circumcenter, what an incenter are. We start off with some fill in the blanks here real quick. When three or more lines intersect in a single point, they are blank. So what that means is, and you can see it down here in this diagram. See how there's 3 line segments? Well, they could be lines or line segments. They don't go on forever on the paper necessarily. But see how there's 3 lines basically, and they intersect at one point right there. That point right there, it is an intersection point, but it's really more of an intersection point when you just have 2 lines. So that's an intersection point right there. When you put a third line there, the lines are now called concurrent. They are called concurrent. So that's what we're going to put here. C-O-N-C-U-R-R-E-N-T. Okay. When 3 or more lines intersect in a single point, they got to intersect at a single point. Like that. Well, kind of. They are concurrent, and the point of intersection is called the point right there, point P, is called the point of concurrency. Very important vocabulary. I don't like to do a ton of vocabulary on these videos because it's boring, but if I don't, you're going to have no idea what I'm talking about when I just start using terms. Okay, so, and it's better to do it in a video than in class when we can really be practicing the skills, So, again, when 3 or more lines intersect in a single point, they are concurrent, and the point of intersection is called the point of concurrency. Point of intersection, point of concurrency. Same thing, but for concurrency, you got to have 3 lines or more. You could have 4. You could have 5. Boom, right? Boom, oops, boom, boom, right? That's still a point of concurrency as long as they all go through that point right there. The circumcenter of triangle ABC is shown below. So what they did right here is and we constructed this in our last lesson, is the perpendicular bisector. So each segment, AB, BC, AC, right? See those? Okay? AB, AC, BC. They all have a perpendicular bisector. You can construct, just like we did in our last lesson, a perpendicular bisector, but 3 of them. When you do all 3 of those perpendicular bisectors intersect at one point, and that point is the point of concurrency. And because you did perpendicular bisectors, it's known as the circumcenter. So that is the circumcenter. It's where the 3 perpendicular bisectors come together. Where the 3 perpendicular bisectors are concurrent. The questions that arise here are, why are the 3 perpendicular bisectors concurrent? And will these be concurrent in all triangles? So if I drew another triangle, just a random triangle, boom, 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 and I did perpendicular bisector, perpendicular bisector, perpendicular bisector, would all 3 bisectors still intersect at one single point? Would they be concurrent, or would they intersect different spots? All right. Recall that all points on the perpendicular bisector are equidistant from endpoints. We talked about equidistance in our last video. So P is equidistant from A and B since it lies on the blank of AB. All right, so P is equidistant from A and B. P is equidistant from A and B because it lies on the perpendicular bisector. Because it lies on the perpendicular bisector. And you could make the symbol for perpendicular is like an upside down T. Okay, so you could do that too. P is also blank from B and C, equidistant. Okay. P is also equidistant from B and C because it lies in the perpendicular bisector. Same reason. Therefore, P must be equidistant from A and C. All right, so that's kind of almost obvious. So AP equals BP equals CP. So AP, I'm going to just draw those out. AP, right, is equal to BP which is equal to CP. See that? So this is equal to this, which is equal to this. So if you connect that point of concurrency, that circumcenter, the circumcenter, and I'm going to just mark it congruent equal just by putting a little hash mark on there. Those are all the same length because of it being the circumcenter. Which suggests that P is the point of concurrency. Of all three perpendicular bisectors. Okay? You have also worked with angle bisectors. The construction of the three angle bisectors of a triangle also results in a point of concurrency, which we call the incenter. So the incenter is when you do three angle bisectors and they all come together at one point. So what we're going to do here, and then we're going to be done with the video, is we're going to construct the angle bisectors here, three angle bisector constructions, and then we're going to see if they intersect at the same point. Okay? And if I do this correctly, which it's difficult on here, it should work. All right, so here's B, here's A, and here's C. So recall the angle bisector construction. So compass point on B, open up the compass, swing an arc. I don't want to do too many big arcs because then it gets we have to do that. I'm talking about the other arcs. We don't want to go too far. But all right, so then you got your new point here. You're going to open up that compass. Let's go outside the triangle just so we're not confusing. And we put a arc out there, and then the exact same compass setting from the other point, put my arc there. All right, so what that did right there is that created my point that I'm going to connect to B. So right here, because I did from B, so right there, and then I take my compass, I take my straight edge here. Oops. I gotta lock. I keep forgetting to lock these pictures. Okay, that looks good. So we'll keep the blue right there. So there's one angle bisector. Okay, we bisected angle B. Now we're going to bisect angle A, change to red. All right, so we put our compass point on A, and we're just going to swing this. Again, we're on a new angle bisector, so it doesn't matter if that part doesn't matter. I just want to rotate it a little bit, get it off this on the screen. All right, I'm going to rotate a little bit more. Alright, so we're going to swing our arc here. And I did change colors because this does kind of get messy. Right? And then from my new points that I just created, I need to swing arcs. I'm going to open up my compass a little bit. I'm going to swing an arc out here. And then from the other point, swing an arc right there. Alright, so again, just doing, we know how to do the angle bisector by now, so this isn't crazy. It's just keeping everything straight is the hard part. So see that point right down there? That's going to get connected to A with my straight edge. And boom, there it is. So there's two angle bisectors. All right, so the red and the blue, and now I gotta bisect C, and we'll use green. Or you want to use purple? Let's use purple. Can we get purple? We're gonna use purple. Isn't that pretty? All right, so we're gonna rotate this around here. C. All right, I'm gonna do a smaller arc this time. We're getting messy here. Right there, because again, it doesn't matter how big the arc is. You just got to have 2 points that are the same distance. So right there and right there, see that? And then from there, see how far we can open up our. Because I want to try and get away from everything. Yeah, that's too much. Do a little bit of a. Let's try and do it like right there. All right. So well, it's different colors, so it's fine. So there's purple. And then last one here, from that point there, swing it around. We want purple, purple. We're looking for the intersection of purple, purple. Ignore the blue, ignore the red. All right, there's the intersection of the purple. The intersection of the purple connects to C. Now you're going to have to do this in class tomorrow, so I hope you're paying close attention. Again, you're constructing 3 angle bisectors. There they are. And perfect. And look what happened. I got purple line, blue line, red line. They all intersect at this point right there. I'm going to make it green, and we're going to call that P. And that P is the in-center. P is the in-center. It's called the in-center. Why is it called the in-center? Because we constructed 3 angle bisectors, and all 3 of those angle bisector lines intersected at one single point. That means they're concurrent. They are concurrent to one point, and that point is the point of concurrency. And because they're angle bisectors, it's called the in-center. If we had done the perpendicular bisectors of the segments, that would have been the circumcenter, which we did earlier. All right, so I will see you in class tomorrow to practice, and you're going to be doing in-center and circumcenter and all that stuff. Have fun.